Okay, welcome to the last section of our section B, which is question 3.3. Question 3.3. So question 3.3 it covers GIS, which is Geographic Information Systems. It covers GIS with Geographic Information Systems. We are going to go through the questions. I've already covered map skills and calculations. I've also covered map interpretation. I'm doing the last part now of our June paper 1 2025. So the first question reads, choose the correct option to make these statements true. Choose the correct option to make these statements true. So the first question reads, A, as you can see, the descriptive data on a map is also referred to as spatial data or attribute data. So if you look at the two, okay, spatial data, remember, you give location or features on a map in terms of its latitude or coordinates, latitude and longitude. That is part of your coordinates. So that's what spatial data is. But when you talk about descriptive data on a map, we are talking about attribute data. What attribute data does is it gives more additional information. Like, for example, we can identify a river as a line feature, or as a line symbol, which is part of spatial data. That is falls under vector data. But the moment we are given the name of that river, it becomes attribute data because it's giving us additional information about that feature. So it's more descriptive in nature. So, okay, so descriptive data on a map is referred to as, that is attribute data. That is your answer there. Your answer there is what? Attribute data. That is the correct answer. That is descriptive data on a map. Spatial data, obviously, showing the location of features on a map. It is georeferenced, which means we are showing the location of features in terms of latitude and longitude. That's what we mean by georeference, in terms of coordinates. So the descriptive data on a map is referred to as attribute data. Then B, data manipulation and data integration involves combining data from different sources to create a more comprehensive view. So the difference between the two, when we are doing what you call data manipulation, we are changing, we are transforming the information or the data that we have collected. Obviously, remember, when we are doing an exercise, be it research or whatever we are trying to collect the data for, we have got an objective in mind, we have got an aim in mind. So if we want to make sure that the data that we have at our disposal can also help us in achieving our aims of objective, we transform, we manipulate, we change data in order to meet our specific designed objectives or aims. That's part of your data manipulation. But when you talk about data integration now, when we are integrating data, we are combining from different sources to create a more comprehensive view. We are combining data from different sources to create a more comprehensive view. So the answer there is data integration involves combining data from different sources to create a more comprehensive view. That is your data integration. Then the next question reads, refer to block C5 on the topographical map and identify the following features. Okay, so we are saying now in this block C5 on the topographical map, this is C5 on the topographical map. You can see this is the block that we are referring to. Okay, so this is the block that we are referring to. The question reads, you can see, refer to block C5 on the topographical map to identify the following features. Okay, so when you talk about the features on the topographical map, remember, we say the data that we have on the topographical map is called vector data, which means it's shown as line, point, and area symbol, or what we call polygons. Okay, this is what we are going to do. Let's look at our question. It's saying now, identify the following features. That is your natural line, which is a line symbol, a human-made polygon, which is an area symbol, a point feature, which is a point feature, a point symbol. Okay, so that's what we are going to do. We are identifying the different types of vector data. That is your line, your point, and your area or your polygon. So from what we have here, a natural line feature. Remember, we've said that our data is divided into line, point, and area symbol. Line, obviously, you remember from my previous lesson that I uploaded, we talked about rows, it's line. We talk about tracking lines, it's line. We talk about rivers as well, also it's line. But the question now is saying a natural line feature, which means what do we have in block C5? We have got these non-perennial rivers, okay? We have got these non-perennial rivers, okay? We have got stream or a river. So it's a stream or a river. That will be the answer for a natural line feature. Then the second one is human-made polygon feature. Polygon now is an area symbol. Remember, when you're talking about vector data under polygons or area symbol, we talked about the vineyards, the orchards, talk about the dams, talk about the cultivated land. But this question is specifically now saying a human-made polygon feature. What do we have here? Let's go to our reference. You can see here, it's an orchard. You can see orchard or a vineyard. If you come here, you can see that's what we have in block C5. It's an vineyard or orchard, which means here a human-made polygon feature is vineyard or orchard. That is the correct answer. Then lastly, a point feature. What do we have in block C5? We have got spot height 834. Point feature. We also have these buildings. These are example of point features. You can see here, these are examples of point features. So we have got our spot height. We also have the building. Those are examples of point features. What I'm simply saying is when it comes to topographical map, remember we have got vector data on a topographical map, which can be line, point, and area symbols. Line, a natural line on this C5, we have got a stream or a river. A human-made polygon, we have got this, which is a vineyard or orchard. Then a point feature, what we have got a spot height 834. We also have the buildings. So those are the different types of vector data that we have. Here they are asking you about vector data on a topographical map, but they are doing it indirectly. So what you need to know is when it comes to vector data, we have got line, point, and area or polygons. Those are the three types of vector data that we have: the line, the polygon or area symbols, and the point symbols. Okay. Refer to the statement below about Orange River located in block B4 on the topographical map. B4, this is our B4 on the topographical map. This is B4 on the topographical map. So it's saying refer to the statement below about the Orange River located in B4. This is B4. Okay. So what are they saying now? Buffering is evident on the either side of the river, which means buffering. We can see the rows of trees here, which is demarcating, which is marking this feature, which is our river. That's where the process of buffering is taking place. Okay, so the question now is saying define buffering. What is buffering? It's this demarcation of a feature of an area. Okay, this is a feature which is a river. It's demarcated by the rows of trees. That's what we mean by buffering. So the concept that you need to define there is buffering. What is buffering? Which is the demarcation of a feature or an area. In this instance, it's a feature which is a river. It's demarcated by the rows of trees. So the concept buffering is the demarcation of a feature of an area or the zoning of a feature. You can see this river, which is Orange River, is zoned by the rows of trees, is demarcated, is buffered by the rows of trees. That's what buffering is all about. Then question B, provide evidence from the topographical map that buffering is occurring on either side of the river on block B4. You can see there is demarcation of this feature, the river, Orange River, by the rows of trees. So there's a row of trees on either side of the river. You can see the rows of trees here, the rows of trees there. So that's all buffering, which is demarcation of a feature, which is zoning of an area or of a feature. That's what buffering is all about. So this takes us to the end of question 3.3 from our June paper 1, grade 12. This takes us to the end. That is 3.3 from our June paper, grade 12, paper 1. Thank you so much.